This is total defects reported versus resolved, and I'm sure a lot of you, if you're test professionals, have used some variant of this chart. Very common chart. So the top red line, cumulative number of defects reported, and the bottom green line is the cumulative number of defects resolved. And we see clients that use this chart exclusively to answer the "Are we ready to ship?" question. And there are at least 4 additional reasons why, or 4 additional questions that you would really need to answer. 4 additional pieces of information where you'd have to say, oh, we need more information before we can decide this. But this chart by itself is not sufficient. So this is an example, again, of metrics without insight. Now, don't get me wrong, I'm not saying don't use this chart, but I'm saying that this chart by itself is not going to be sufficient to answer that "Are we ready to ship?" question, yet we see a large number of clients that do indeed use a chart just like this in an attempt to answer that. Okay, so here's another surprise. Even smart people jump to conclusions. And this quote from H.L. Mencken here, one of my favorites: "For every complex problem, there is an answer that is clear, simple, and wrong." And we see that during assessments. There is a desire to have a simple, obvious explanation of why something happened or how a problem can be made to go away. And this ties back to the previous surprise that I was talking about, the lack of sufficient data, if you will, that having lots of metrics but not necessarily the right metrics. And the way that this manifests itself during an assessment, how we see this happening, is that we'll hear a hypothesis put forward during an interview. Somebody will say, we have problem X, and it's because of Y. We have, it takes too long for the testers to find the important bugs, and that's because they don't understand our customers and how they use the product. That's an example of that hypothesis of problem, reason, or in this case, problem, scapegoat. Now, that could be true. It could be true that the reason that your bugs are being found late in the game is because the testers don't really understand the product, and they're learning the product as they're testing it, and it's only once they've achieved a certain degree of sophistication that they start finding important bugs. And depending on the test strategies that you find, that might actually exacerbate that very problem. But without some sort of careful analysis, objective proof of that hypothesis, should we accept it? Should we act on it? Unfortunately, in a lot of cases, we have seen people ready to act on these conclusions that they've reached that sound very reasonable, but unfortunately are wrong, which of course is the most dangerous kind of wrong. And they're ready to go forward and make changes based on this conclusion that they've jumped to when the data is actually not there to support it. And as I said, that's the thing that's wrong, but sounds reasonable, is the most dangerous kind of wrong. Here's an example. I'll come back to that most dangerous kind of wrong point in a minute. Doing an assessment for a client a few years ago, and I want to mention something here that perhaps I should have mentioned at the outset, but it's I want to make sure that it's clear. I am not talking about dumb people here. I'm talking about very, very smart people. These surprising findings are not surprising because I'm surprised that people could make such mistakes. I think we're talking about things that are elemental in human nature. The desire to have a simple explanation that makes a complex problem go away, or at least a complex problem appear simple and its solution simple, is something that is very attractive to people. And here's a case study of that. We had a client a few years ago. We're going through the assessment process. And people are saying, it seems like there are a lot of rejected bug reports. Now, by rejected bug reports, I mean the bug report ultimately turns out to be a non-issue. In other words, the behavior of the product is correct. So people are saying, well, it seems to be a large number of rejected bug reports. And that part was right. We looked at the percentage of bug reports that were rejected, and in their parlance, they called that closed, which is a little unusual from a terminological point of view, because closed often means closed with a fix rather than rejected or canceled. But in this case, they called those closed as non-issues. And indeed, there was a fairly high percentage. I think it was around 15% or so overall, maybe a little bit higher than that, 15, 20%. And usually we would like to see that when we look at metrics in an organization. We like to see that number around 5%. Once it gets above 5%, that's when we start to say, what's going on here? Well, people were saying, the rejected bug report rate seems to be pretty high. They immediately would follow that up with, at least most of them would immediately follow it up with this comment of, the reason that happens is because the testers don't have enough experience with the use of the product. Now, this is an industrial control system, and it was used in various kinds of factories and refineries and pharmaceutical plants and things like that. So it's industrial control software. It's pretty complicated stuff, and it's obviously quite mission critical. And the use of it and the defects that it could experience are quite subtle. So this is very reasonable to say, if the testers don't have enough real-world experience working in plants and factories and refineries and so forth with products like ours, they're not going to be able to understand proper use of the product, and therefore they're going to file a lot of spurious bug reports. It's a totally reasonable hypothesis. And it would have been very easy for me to have come forward with a report that said, yeah, you guys, you need to get rid of some of your less experienced testers, the ones that have less time in factories and plants and so forth, and really try to focus on hiring people with more experience. But before jumping to that conclusion, I said, okay, this is a testable hypothesis. I asked the test manager to give me the data for the bug reports, the percentage of bugs that had been rejected, broken down person by person. I told him, I don't need to know the name of the person, but I do want you to tell me how many years of actual plant experience, real-world experience, you think that person has. So just give me a spreadsheet that contains 2 columns of numbers side by side, percentage of rejected bug reports, number of years of actual experience using products like this in plants and refineries, and so forth. I run a scatter plot. The scatter plot you see on this screen is what came up from that. And for those of you who remember your statistics probably better than I do, you look at that R-squared value you see over at the right side on the middle of the screen, and R-squared is 0.0166. And that basically means that there is no statistical correlation. And even if you don't remember your statistics, I mean, you can clearly see that there really does not seem to be any sort of connection. I mean, yes, you have people who have what would appear to be maybe a limited amount of experience, less than 5 years, filing a large number of bug reports that get rejected, but there were people with a lot more than 5